Next question of the topic line integral is this question number 13. Prove that f vector equals 2x z cube plus 6y I vector plus 6x minus 2y z j vector plus 3x square z square minus y square k vector is conservative vector field. Also find scalar potential function. So if we have asked irrotational or conservative or line integral is independent of path, then simply we have to do we have to prove curl of f equals 0 to be a conservative vector field. So curl of f is written as grad cross f, and this grad is I dy dx plus j dy dy plus k dy dz, and cross f vector is 2x cube plus 6y I vector plus 6x minus 2yz j vector plus 3x square z square minus y square k vector. To do the cross product, we have to expand the determinant. In determinant form, it is I j k in the first column, and in second column it is in second row it is del by del x, del by del y, and del by del z, and in last column coefficient of I vector 2x z cube plus 6y, coefficient of j vector 6x minus 2yz, and coefficient of k vector 3x square z square minus y square. So we need to show this as 0. Now expanding this, first is I vector, and remove this column and this row. Remaining is del by del y of 3x square z square minus y square. So there is no y, so derivative of constant is 0, and here is minus y square, so derivative of y square with respect to y is minus 2y, and minus this dy dz of 6x minus 2yz. There is no z, so it is 0, and minus minus plus, so here is z, so 2y is the constant, and derivative of z with respect to z is 1. And similarly for j vector is this del by del x of this. So except x is the constant, so 3 x square is constant, and derivative of x square 2x, so 6 x z square minus this del by del z of 2x z cube plus 6y. Since here is z, so 2x is constant, and derivative of z cube with respect to z is 3z square, so 2x into 3z square, that is 6x z square. So it cancel off, and this also cancel off, and remaining is for k vector, so cancel this column and this row, and remaining is dy dx of 6x minus 2yz is k, it is with respect to x, so it is 6. So here is no x, so it is 0. So minus here is no term of y, so here is 6y. Derivative of 6y is simply 6 and also cancels. So 0 minus 0 plus 0 is simply a 0. So it is yes, 0. Now also we have to find the scalar potential function. Let that function be phi, so f vector equals grad phi, and taking dot product in both sides we get f vector is this, and multiplied by dr vector is, in previous question I have told that dr vector is I dx plus j dy plus k dz. So taking dot product of these two we get this, and grad phi of dr is d phi, as from previous question. Grad phi of dr is simply d phi. Now solving this we get this, and we need to arrange into this form, which can be easily converted into exact form. Now first x dy plus y dx is dxy, because dxy is using product rule. First function derivative of second function plus second derivative of first. X dy plus y dx is same thing as dxy, and 6 in outside, and we need to also convert this in the exact form. So derivative of this x square z cube is first function as it is, derivative of second is 3 z square plus second as it is, derivative of x square is 2x, so it is 2x z cube, and with respect to x also here with respect to z, so z cube 2x z cube dx and 3 x square z square dx. So this is the same thing as derivative of x square z cube, and finally we need to convert this into exact form. So it is the highest power in both is this y square, so y square, and the remaining function is this z, so z. Now we need to cross check it by expanding as this y square as first function and z as second function. So differentiating first function and differentiation of second function plus second differentiation of y square is 2y dy. So it is the same y square dx and 2yz dy. So it is the same thing as dy square z. So on integrating, this derivative sign cancels, so it is, and phi equals x square z cube plus 6xy minus y square z, and the constant c. This much for today. Take care.